Baker. We're representing BrewBlue, well, ex-BrewBlue, and we're going to kind of explain why it's ex-BrewBlue, and we're going to kind of go through what we have done through the semester and what has been going on the couple past weeks. So we started last semester as our project of trying to process the waste in microbreweries, the wastewater microbreweries, and this is important because microbreweries produce around 3 barrels of wastewater per barrel of beer. So there's a large, it's here, just because we're going to be switching around. So there's a lot of wastewater being produced, and this is kind of, it's not really a direct strain to the environment, but it's indirect as it goes into the industrial scale of processing the water, which then adds some strain to it. And previously we were working with Biogas. We were kind of like a project that started in Biogas and now has matured into its own team. So what we wanted to do was reduce the impact that microbreweries had on the environment. It is kind of an important thing as they're very related, they're very closely tied to the community. We wanted to empower small businesses as there is very little, so there is no wastewater treatment plants that are available, as Marina's going to say it in a minute, for like small microbreweries. They're mostly for bigger microbreweries. And then we wanted to educate the community of microbreweries on like different sustainable practices.
So the problem that we were looking at in BrewBlue was the waste from the microbreweries being deposited directly to the local municipal treatment plants. And the problem with this is the high chemical oxygen demand in the effluent can and does adversely affect the treatment system. And so these treatment plants are around the country are beginning to find breweries to deposit their waste. And so far in Michigan, there's not really a fine for breweries depositing their waste, but the microbrewery industry is actually growing at a pretty high rate, and so it's a foreseeable issue that fines can come up in the future. And in addition, the microbrewery industry is really interesting because they really value sustainability and community service. Here's an example. Sierra Nevada has wastewater treatment plants, and they really value sustainability in their practices. But as with any other business, they need economic incentive to implement any sort of solution. Okay. So most larger breweries have an on-site anaerobic treatment, and there's much literature on using the upflow anaerobic sludge blanket to treat the waste for larger breweries, and there's not so much going on with smaller breweries. And in addition, one of our main goals was to maintain contact with the community, and that required us to maintain a relationship with several local microbreweries in Ann Arbor and around Michigan, and we also made several visits of the Corner Brewery.
So after kind of a semester of research on the microbreweries and keeping contact with them, we were able kind of pilot a plan around one of the specific microbreweries. We focus on the Corner Brewery, which is one of the Arbor Brewing Company's like sub-breweries, or the biggest one. Basically, it's in Ypsilanti, and they produce 3 double batches a week. A batch is 21 barrels, and a barrel is 31 gallons. So they do produce a lot of beer, but it's really not. It seems like a lot, but for a microbrewery, it's just barely hit the target of being a microbrewery. So like Jolly Pumpkin produces 10,000 gallons a day, so it's not really that big. And then a microbrewery is kind of distributed. It's kind of different reactors put around in a room, and the beer itself is processed throughout the reactors, and it kind of hops around. And each like cycle or like movement of the water, it creates some wastewater. And out of all those movements, there's 2 parts where they create organic wastewater, which is the wort and the yeast. The wort is first, which is why it has a high flow rate. That's when it gets to the yeast, it's more concentrated and there's less water coming out. But as you can see, the yeast also has a lot higher COD. COD is kind of like the chemical. It's like the organic chemicals being suspended in the organic waste. And those COD values, we processed them in the lab, and those were the ones we got with. They're pretty high. They're normally normally like milligrams per liter. So they're really high and they're really concentrated. And from those, we then kind of scaled up and tried to design a system around those two streams, trying to eliminate big flow rates. So the requirements was to reduce COD. As you saw, they were pretty high. We wanted to reduce them the least possible, but it's normally less than 20. You don't get fined in places that are not Michigan. Michigan doesn't get fined at all. And then we want to generate biogas because there has to be an incentive for the businesses to want to implement this design. So we had to display some of that cost through biogas, which is equivalent to natural gas. So for every kilogram of COD, you produce around 350 liters of methane. And the price of natural gas or methane is around $5 per million BTUs, which is, you probably get your gas bills in therms, so that's like 10 therms. So our actual project, once we ran all the numbers, we could heat up 1,000 gallons per week, which is almost all the water they heat up. And this is from 22 Celsius to 78 Celsius, which is the temperature they normally process their wort with which they leach the grains. And this would be equivalent to $72 per week of gas reduction. And it would reduce the COD of the yeast to 35 and 17, which is pretty good. And if you like mix the streams, it's almost acceptable to put it into rivers. But the cost of a digester is $150,000. This is scaled down as kind of like an economic process econ. We use some process econ to scale down a off-flow anaerobic sludge blanket, which is the one that Marina was talking about. And the ones that are existent right now are really big. They're 50 kiloliters, so 50,000 liters, and they're being used, and their cost is around $700,000. So if we scale down, it's $150,000, and the payoff was 42 years, which is longer than the lifetime of the reactor. So this is not like economic sustainable at all, and it wouldn't be. There's no incentive for a business to want to invest in that. So after kind of looking around, we decided it was not sustainable for us to keep working on a project with microbreweries, as there's no incentive for them to want to invest such amount of money and get so little in return. And even if they do get charged for COD, as you'll see, you won't see later, but even if they do get charged, it's still not enough displacement of cost to make that huge capital investment worthwhile. So we decided to kind of change to a different target group, which is what we're doing now. That was around 3 weeks ago, I think.
Yeah, so since then we've kind of had a fresh start from BrewBlue, and we're going to be using all the expertise we gained from working on BrewBlue, such as anaerobic digestion, economic incentive, like working with local businesses, and we're looking to apply this expertise to our new project. So even though we're starting on a new project, we're not starting completely from scratch. So the project vision for our new project, which also doesn't have a name, so we're accepting suggestions. We're looking to promote sustainable waste utilization on campus and in the Ann Arbor community. And we're looking to find a way to process waste that would otherwise decay in landfill, so it has an environmental impact. And also, we're hoping to foster a relationship between the students, local businesses, and the Ann Arbor community with the system. And our new project would tie in very well with BLUElab's mission. We would be improving the environmental outcome, and we'd also there would be a large emphasis on educating the community about sustainable practices. Oops. So previous research is obviously the research we've done in BrewBlue. So we've looked at anaerobic versus aerobic digestion, the costs and benefits of both, optimization of choosing waste streams, the reaction kinetics in the reactor, and also the wastewater regulation in Michigan. And the main problem that we are looking at is an issue of awareness. Many students and many community members don't realize the value of waste, specifically organic waste, and they don't understand the impact that waste has. and alternatives to disposal. And then so this fits in really well with this year's new BLUElab lifestyle initiative, and we would help in promoting sustainable lifestyle for students.
So before we can kind of start, we have to figure out if there is this. Well, first we have to see if the project is feasible, which this is the engineering part. Like if the digester or processing the waste is a possible outcome, and if the products that we get are valuable at all. So that is not at all the hardest part because we already have all the knowledge we have from the previous project. However, we kind of have to see if we kind of have to see more the social aspect of like what the students are doing right now and what value they put on their waste and what value we have to put on the waste for them to have incentive for them to give us their waste and us to process it. And then we have to see how much waste is being produced per student and how we can collect this efficiently and not incur really big costs while collecting them or not making students come to us, which no one will really want to take their waste to like this location random because we have a limited amount of time as students. So we're designing a survey. It's going to be done by Monday, and we're going to start going out. The first target area is Carytown because it's close to a farmer's market. We're going to start talking to students and see what their current practices are. Some other projects that already exist that are similar to ours, there is many composting projects. So we would try to focus on anaerobic digestion. Well, we hopefully will because there is, well, the market on composting is kind of saturated, but there is in U of M, there's like some in Ross, there's some different student groups that are doing composting, there's some classes that are doing composting. Ann Arbor has a composting site where you can go and give them your waste and you get charged by the ton, so we would also try to avoid charging students. And then there's some student like food group, like co-ops have composting sites and stuff like that don't really work in the winter, but they do still do composting. And then this picture in your right is the Corners Brewery composting. So they kind of designed this small composting site for themselves for the restaurant that they have on site. So for our design to work, it has to really be aware of what the problem in the community is and address that because we will be relying on students for their waste. We need some reward to make an incentive for students to give us their waste because we'll have limited time and you don't really want to go out of your way to help this small group. And then it has to be unique to the other groups because there's already a lot of like startups or ventures on like collecting waste or different stuff like that. And it has to be sustainable, both environmental, economical, and cultural. And hopefully if we are able to meet all this like sustainable aspects, it will also be sustainable through time. As we were analyzing other projects, a lot of them are kind of like burst as they're like more like month or 2 months, and then there's an award and it ends up, and we want to make it kind of constant so it has like a prolonged effect.
So we have many questions remaining since we're just starting out this group, but some of the major questions we're looking at are what groups should we target for collection of waste? What will make waste like sorting, depositing like worthwhile for someone to do, like in terms of a reward for that? Who can benefit most from our outputs? So outputs would include biogas if we're doing anaerobic, and slurry, which can be used for fertilizer. And we're also looking at the possibility to partner with a local business. And the major problem we're looking at is the feasibility because we've encountered problems with that. And so in conclusion, we were able to learn a lot from our past mistakes and our past successes. This is from a survey from the members of our group. They said they learned about many important steps in the design and collaboration, especially across multiple disciplines of engineering. So we were able to learn a lot last semester, even though it didn't end up being successful. And we're also looking to establish a new vision of the value of organic waste in the community. And we're also just trying to show that environmental improvement requires effective social change, and sometimes that's the hardest part of implementing a solution. And in addition, we want to thank BLUElab for their support. So, any questions?
So as you're leaving the brewery, how do they feel? And like, would you think they'd be willing to
So we have a really close ties with the Quarter Brewery more than anything, more than other breweries, just because they're the ones that we kind of went over a couple of times. We did testing on their like streams, and they were kind of disappointed that we were not gonna do it, and they were, I don't know, like we were talking to one of the process engineers, and he kind of didn't understand. He still wanted to do it, but it didn't make sense for him at all to want to do it. And then so they're willing to help us in this new project. They may give us some of their waste. They have like spent grains. They already do some stuff for the restaurant, but they are willing to help us, and they have a ton of contacts, and they kind of recommend us to people all the time.
You guys thought about looking at the dining halls at all, like what they do with their organic waste? Because it seems like that's a huge percentage of where people, like students, are going with their organic waste.
We have looked at the dining halls as like a huge input, but we're not sure if there are currently any processing of the waste in the dining hall, which is something we have to look into. But that's one of our possible inputs.
It's also, the dining hall is very competitive. Like there's a lot of, it's kind of surprising. There's a ton of student groups that are working towards it. There's a class, there's a startup by a PhD student. So there is a lot of people that are targeting it because there's a lot of waste being outputted by the dining halls. So it would kind of be a little harder, but it's definitely a possibility.
I know they sort it. I used to work in one, and they do sort it.
They do?
Yeah.
Okay, that's good.
Yeah, I know for a fact that our faculty advisor, Professor Skurlos, he's actually worked on a similar kind of project, which he worked with reusing the grease as collection means in order to prevent it from being just normally dumped. So you may want to talk to him about those kind of aspects.
Yeah, he's advising us, so it's kind of nice.
Something that might be more centralized to the college is looking at the Ginsberg Center. They have that community garden out there. That might be a good place to have some sort of biogas digester that is supportive of that garden, if that makes sense.
Yeah. So we didn't really talk about it because it's kind of way into the future, but anaerobic digestion produces fertilizer. It has a couple, apart from biogas, it produces fertilizer when it's processing solid waste. So our plan was to get value out of that fertilizer by kind of selling it or in exchange to a farm, and we're looking to what farm we want to. We were thinking about Singerman's, but that is kind of also an option.
I know the campus also has a farm. You could look at the farm.
Yeah.